Hello, as promised in this video, I will show how to use the custom OpenPlanner simulator for testing controller or OpenPlanner or any functionality using CARLA simulator or even the real car. We can call it simulation in the loop as a testing paradigm, but it's simply we just trick the vehicle that there is an obstacle or another car, and it reacts according to a virtually inserted object instead of putting a real object. So in this test we are not testing the perception, we are testing the planning and control part only. Of course, if we want to test perception, we need to test the sensors and the perception pipeline and tracking and so on. But if we want to test the planning separately and control separately, this is very handy. So to start, we need to modify some as we see, we modified some parameters in the launch files for the AutoWare pipeline. First, I showed this before. Let's have a look again. In the devel.launch, there is two main parameters. I said enable OpenPlanner simulation and enable object insert. We enable the simulation and we enable object insert. If we disable object insert, we will use another vehicle which running virtual vehicle which running OpenPlanner, another version, compact version of OpenPlanner on that vehicle. We'll see both. First, the simple simulation, which is we can using the marker on Rviz, we can insert an obstacle anywhere we want. Okay, we enabled that. Where we in the launch file enable this. For the simulation, generally we enable that in the object detection perception. There is a node called OpenPlanner OP Perception Simulator, which publish a point cloud as if it's detected by a LiDAR. And of course, this is the flag we check to enable this, and if this flag is true, then we disable the Euclidean cluster. Of course, we don't want a conflict between both the simulated perception and the actual perception. Okay, let's start and see how this works. I run Roscore simulator and Rviz. I need to run to the devel.launch. Let me check if the in the controller, if we still enabling the simulation or not, the calibration or not, sorry. In the high level controller, we check yes, manual calibration false, then that's perfect. We started, we check here, we localize. There is no, we can't see the detected obstacles now because it's running the simulated perception simulator. So let's select a target. One issue here, we don't have a lot of option to insert points, so we use the 2D nav. I use 2D nav goal to insert both the goal point for the global planner and the obstacle. So I need to click twice to move the obstacle again. Let's select a goal point. Let's say here. Then the vehicle will start. If we see here, these are the predicted trajectories for this object. Then I wanna put it in another place, for example here. So now I inserted obstacle here. That's the obstacle, and because it's on the lane, the motion prediction thinks that it's a vehicle, so this is the estimated trajectory for this vehicle. So now the vehicle is coming close, it detect, go into follow mode, and then hit the obstacle. Okay, now it didn't brake early. As I said before, this is a tuning parameter, so let's tune it and try again. Of course we can move anytime if we want to try. Insert obstacle here, so obstacle moved in front, vehicle is still in follow mode. It tried to move as close as possible from this, and of course we can insert this anywhere. Here there is no lane, it's just an obstacle. We can insert it here, so we use this and insert it anywhere. Because we enable multiple object insertion, goal insertion for the global planner, it also insert a global, a goal for each one, but it doesn't matter. Our global planner replanning option is disabled, so this will not have any impact on our testing. Let's fix the stopping problem for the obstacle and come back and test again. So the problem might be the velocity, the current speed, maybe its car is driving faster, or the deceleration itself, the average deceleration, or stopping distance. One solution is to increase the stopping distance here from 15 meter to 20 meter, the minimum follow safe distance. Also we can increase the braking, the PID controller, the P controller, so we can start braking much earlier. Also we can increase this, the engine brake. We say, okay, engine brake is higher or lower. Actually, if we make it lower, we use the brake earlier than expected. So with this modification, let's try to do the same test again. Okay, car is localized at this position. I'll make the same test, so same goal, and car start moving. Then I will insert it here at the same place. And now let's see what will happen. Of course we can see here how is the car navigates the environment. It enter follow mode and successfully braking before the obstacle. Another test, let's move it here a bit further so it accelerates and brakes before the obstacles around 8 meters from the obstacle. So successfully we for this configuration we set the distance for the braking in the normal circumstances. this will happen over and over, so it's predictable results.